Bada bing. All right, so we gotta do the fourth root of x to the fourth over the fourth root of y to the eighth. So again, when you're taking like exponents, and we talked about taking square roots of exponents, they all had to be even exponents to be perfect squares. And the reason they had to be even exponents is because they were all divisible by 2. So this is just going to be x, because we take that and divide by that. And then here, that exponent divided by that makes that a y squared. So we have x over y squared. Okay? All right. Motoring right along, guys. Motoring right along. Another one to look at. 6xy to the 1/2 divided by 2 x to the 1/3 z to the -5. Okay, and they want us to simplify this. Well, let's do our numbers first. Okay, let's do our numbers first. 6 divided by 2 is 3. And then here my x's, I'm going to make this a 3 over 3. So when I have x to the 3 over 3 divided by x to the 1 over 3, that's going to be x to the 2/3. Okay, and my y to the 1/2, there's no base in the bottom, I just leave that. And what happens with my z to the -5? If it's a -5 in the bottom, I bring that little fella up top and make it z to the 5th. Okay? All right, here we go. The final stretch. This is a really long section. This is probably one we'll spend a few days on. Okay, at least a few days. So, the 5th root of 5a to the 5th, b to the 9th, c to the 13th. Now, before we do that, I want to try one like this. Something that's more familiar to us. Okay? So for this, what did we do? We made it perfect square part, leftover part. Is 7 a perfect square? No. Are any factors of 7 perfect squares? No. So 7 goes here. Okay? a to the 6, is that a perfect square? Yes. It's an even exponent. It's divisible by the number that's here. This is understood to be a 2. Okay, but we don't write it because we don't have to. It's a square root. Okay? Just like if I say x, you don't have to write 1x. We just say x. Okay? So if there's no number there, it's understood to be a 2. We're talking about a square root. It's the most common. So that's a perfect square. Now, is b to the 7th a perfect square? No. But b to the 6th is. And then I got to put a leftover b over there. C to the 9th, is that a perfect square? No. But c to the 8th is. Okay, and then we take the square root of a to the 6th is a cubed, the square root of b to the 6th is b cubed, and the square root of c to the 8th is c to the 4th root 7bc. Okay, so coming over here, we're going to put on our big boy and big girl pants to do this one. Perfect 5th roots, leftover 5th roots. 5 is all left over, man. There's nothing happening there. Okay? But I look at a to the 5th and I wonder, is that a perfect 5th root? And I'm going to tell you that yes, it is. It is a perfect 5th root. Okay? Why? Because 5 is divisible by 5. Is b to the 9th a perfect 5th root? Does 5 go into 9 evenly? No. But it goes into b to the 5th, and it gives me a b to the 4th left over. How about c to the 13th? Does 5 go into 13 evenly? No. But it goes into c to the 10th. We have c cubed over there. So the 5th root of a to the 5th is a, the 5th root of b to the 5th is b, and the 5th root of c to the 10th is c squared times the 5th root of 5b to the 4th c cubed. All right? Here's one for you. Let's do the 6th root. How's that? We'll do 8, a to the 7th, b to the 14th, c to the 20th. Pause that video. Pause it. Give it a shot. I wish I could see through the camera and see if you're actually pausing your videos. I know some of you aren't. I know some of you aren't. All right, let's see what we have. Let's see what we have. So, perfect six, excuse me. Perfect sixth root, leftover sixth root. 1 to the 6th is 1. 2 to the 6th is 64, so 8's got to go over here. It's left over. A to the 6th times A. B to the 12th. B squared. C to the 18th. C squared. Okay? So, the 6th root of A to the 6th. Well, we know that's A. And the 6th root of B to the 12th is B squared. The 6th root of C to the 18th, that's actually C cubed. Times the 6th root of 8A, B squared, C squared.
Good morning.